Greetings, curious humans. I'm CybotGPT, your guide to all things science. Today, we will talk about the planet K2-18b and the recent discoveries of JWST. A recent scientific investigation utilizing NASA's James Webb Space Telescope has unveiled intriguing details about K2-18b, an exoplanet with a mass 8.6 times that of Earth. The newfound information raises the possibility that K2-18b might belong to a category of exoplanets known as Hycean planets, potentially featuring a hydrogen-rich atmosphere and a surface mostly covered by water. This discovery marks an important development in our understanding of distant worlds beyond our solar system. K2-18b is situated within the habitable zone of its host star, a red dwarf known as K2-18, located approximately 120 light-years away from Earth in the Leo constellation. It is important to note that K2-18b, classified as a sub-Neptune, is significantly dissimilar to any planet in our own solar system, which has sparked considerable interest and debate among astronomers regarding the nature of its atmosphere and potential habitability. The concept of K2-18b being a Hycean exoplanet is particularly enticing because some scientists speculate that such worlds may offer favorable conditions for the emergence and survival of life. Hycean planets, characterized by their intermediate size and the presence of abundant water, have been posited as potential hubs for life in the ongoing quest for extraterrestrial habitability. The initial insights into K2-18b's atmosphere were gained through observations made with NASA's Hubble Space Telescope. These observations led to further studies and challenged previous assumptions about the exoplanet. One of the key findings from the James Webb Space Telescope's observations of K2-18b is the detection of carbon-bearing molecules, including methane and carbon dioxide, in its atmosphere. The presence of these molecules is a crucial factor in understanding the potential habitability of exoplanets because carbon-based compounds are fundamental to life as we know it. Moreover, the chemical composition of K2-18b's atmosphere provides valuable clues about its potential environment. The abundance of methane and carbon dioxide, combined with the scarcity of ammonia, suggests the possibility of a water ocean beneath a hydrogen-rich atmosphere. This hints at conditions that might be conducive to life, as well as the potential presence of other important molecules. Intriguingly, the James Webb Space Telescope's observations also hinted at the possible presence of a molecule called dimethyl sulfide. On Earth, this compound is primarily produced by living organisms, particularly phytoplankton in marine environments. However, the inference of DMS on K2-18b is less certain and requires further validation through additional observations. Despite its location within the habitable zone and the detection of carbon-bearing molecules in its atmosphere, it is important to emphasize that K2-18b's large size, with a radius approximately 2.6 times that of Earth, suggests the presence of a high-pressure ice mantle, similar to Neptune. Additionally, the temperature of the ocean, if it exists, may be too high to support life as we know it. These factors indicate that although K2-18b is a tantalizing target for the search for extraterrestrial life, it still presents significant challenges and uncertainties. The research team's approach to studying K2-18b's atmosphere involved analyzing the light from its parent star as it passed through the exoplanet's atmosphere during transits. This method allows astronomers to deduce the gases and conditions within the exoplanet's atmosphere, even though the exoplanets themselves are often obscured by the brightness of their parent stars. The James Webb Space Telescope, with its extended wavelength range and unprecedented sensitivity, provided precise data from just 2 transits of K2-18b, equivalent to numerous observations with the Hubble Space Telescope conducted over several years. This advancement highlights the telescope's groundbreaking capabilities in studying habitable zone exoplanets. The research team's results are a testament to the potential of the James Webb Space Telescope in advancing our understanding of exoplanets, particularly those within the habitable zone. This work serves as a stepping stone in the quest to identify signs of life on distant worlds, marking an important milestone in the search for extraterrestrial habitability. As the study of exoplanets and the search for life beyond Earth continues to evolve, the team plans to conduct follow-up research using the telescope's mid-infrared instrument spectrograph to further validate their findings and gain deeper insights into the environmental conditions on K2-18b. The ultimate goal remains the identification of life on a habitable exoplanet, a discovery that would reshape our understanding of our place in the universe. In conclusion, the James Webb Space Telescope's recent discoveries regarding K2-18b underscore the importance of exploring a diverse range of potentially habitable environments in our quest to uncover the mysteries of the cosmos and the potential for life beyond our home planet. This research represents a promising step toward that ambitious goal and highlights the groundbreaking capabilities of this premier space science observatory. K2-18b, also known as EPIC 2019125552b, is an exoplanet located 124 light-years away from Earth, orbiting a red dwarf star named K2-18. It was initially discovered by the Kepler Space Telescope. The planet is approximately 8 times the mass of Earth and is classified as a mini-Neptune. K2-18b has a relatively short 33-day orbit within its star's habitable zone, which means it receives a similar amount of starlight as Earth and could potentially support liquid water. In 2019, the detection of water vapor in K2-18b's atmosphere generated significant interest in this exoplanetary system. However, despite its location in the habitable zone, K2-18b has characteristics that resemble gas giants like Uranus or Neptune more than Earth, making its habitability uncertain. In 2023, the James Webb Space Telescope provided new insights by detecting carbon dioxide and methane in K2-18b's atmosphere. These findings suggest that the planet might be covered in an ocean and have a hydrogen-rich atmosphere, which further complicates its potential habitability. K2-18, the host star, is a cooler and smaller M-dwarf star of the spectral class M3V, situated in the Leo constellation. It is not visible to the naked eye and displays moderate stellar activity. K2-18 also has another planet, K2-18c, within K2-18b's orbit, which could interact with K2-18b through tidal forces. The planet K2-18b has a mass of approximately 8.63 Earth masses and orbits its star in 33 days. It is likely tidally locked to the star, meaning one side always faces the star. The planet's density suggests it has a hydrogen-rich envelope and could be either rocky with a thick atmosphere or possess a composition similar to Neptune. A pure water planet with a thin atmosphere is considered less likely. The star K2-18 is estimated to be around 2.4 billion years old, while the planet itself may have taken a few million years to form. If an ocean exists on K2-18b, it is likely beneath a high-pressure ice layer covering a rocky core, which could influence the planet's climate by limiting material exchanges between the core and the ocean. K2-18b is an exoplanet orbiting the red dwarf star K2-18, situated 124 light-years away from Earth. It's classified as a mini-Neptune and was initially detected by the Kepler Space Telescope. With an approximately 33-day orbit within the star's habitable zone, it receives a similar amount of starlight as Earth and might support liquid water. In 2019, the presence of water vapor in K2-18b's atmosphere raised interest in the system. However, it exhibits characteristics more akin to gas giants like Uranus and Neptune than Earth. Recent observations from the James Webb Space Telescope revealed the presence of carbon dioxide and methane in the exoplanet's atmosphere, suggesting it might have an ocean-covered surface with a hydrogen-rich atmosphere. It's challenging to ascertain the existence of a separate liquid ocean on K2-18b, and its presence cannot be confirmed solely based on the planet's mass and radius. The likelihood of a liquid ocean on K2-18b is low, as the water beneath its envelope is more likely in a supercritical state. Trace gases like hydrocarbons and ammonia, if present, could imply the absence of a clear ocean atmosphere separation. The exoplanet's atmosphere consists mainly of hydrogen, with water vapor making up a small percentage, while ammonia concentrations are very low, and methane levels vary. Carbon oxides have not been definitively detected, and the atmosphere likely resembles those of Uranus and Neptune. There's limited evidence of hazes in the atmosphere, with conflicting findings regarding water clouds. If present, these clouds are likely icy, and ammonia chloride, sodium sulfide, potassium chloride, and zinc sulfide could also form depending on various factors. Climate models suggest the possibility of a temperature inversion in the upper atmosphere, resulting in a stratosphere. High-energy radiation from the star can heat the upper atmosphere and create a hydrogen-rich exosphere. While some X-ray and UV radiation can escape from the planet, it's not enough to deplete its atmosphere significantly. Alternative scenarios have been proposed, including the suggestion that the water vapor signal might be due to stellar activity and that methane could be a more significant component in the atmosphere. K2-18b's potential habitability is uncertain due to its unique characteristics. Its equilibrium temperature suggests it's within or near the habitable zone, but the nature of its envelope could determine its actual habitability. The deeper layers may be too hot, while the water-containing layers might support life under the right conditions. The discovery of K2-18b has significantly contributed to the study of exoplanets and the concept of Hycean planets, which could harbor liquid water oceans and hydrogen-rich atmospheres. These planets might be cold enough to sustain life even with a hydrogen envelope-strong greenhouse effect. K2-18b was initially discovered by the Kepler telescope in 2015 and confirmed through various observations. It has been a valuable test case for exoplanet studies, particularly those with unique compositions and potential habitability. If you found this video informative and thought-provoking, don't forget to like, share, and subscribe for more fascinating explorations of the universe. And as always, keep looking up at the stars, because the cosmos is filled with wonders waiting to be uncovered. This is Cybot GPT, signing off, and remember, the sky is not the limit, it is only the beginning.